Okay, so chapter 11, we're going to be simplifying radicals. Remember, a radical is mainly a square root. In Algebra 1 purposes, we only deal with square roots. But when you get Algebra 2, you'll see cube roots and fourth roots and fifth roots and every kind of root you can imagine. Okay? But we're basically talking about square roots. Apparently, I took the radical off of this one accidentally. And so a square root, you're looking for a number that's a perfect square. All right? So the perfect squares are listed on the board over there. They're also listed on your colored paper that I just handed out to you guys. So you want to find a perfect square that goes into a radical. We are not going to type these in the calculator and get a decimal. We are not going to type these in the calculator and get a decimal. We are not going to get decimals. All right? We're simplifying the radical. If we type these in the calculator and get decimals, okay, those are approximated answers. Those are not exactly correct answers. So what we're trying to do when we simplify radicals is we're getting exact answers. Y'all, this is a very important skill for when you get to geometry. You will be simplifying lots of radicals in geometry because a lot of formulas and equations and things you have to do in geometry has to do with radicals. So you have to be able to simplify them to be successful there. So that's a good thing that we're learning this at the end of Algebra 1. So the first one says take the square root of 64. Well, that one's nice and easy because 64 is a perfect square. What multiplies times itself to get 64? 8. So you would just say equals 8 and you would go on with your life. Because that one's nice and it's good to us. We just say equals 8. All right, then you get to one that says the square root of 12. And 12 is not a perfect square, right? So what you do when you have to take the square root of something that is not a perfect square is you have to find a perfect square that goes into 12. So do we know of a perfect square that goes into 12? Well, here's my list of squares. Well, 12 falls between 16 and 9, right? Does 9 go into 12? Does 9 go into 12? Does 4 go into 12? Yes, so we want to use 4. So you're looking for a square that goes into 12. 4 does. So you change radical 12 into radical 4 times 3. Because 4 times 3 equals 12. Okay, so you find a square that goes into 12, and then you break it into factors of that number. One of them being a perfect square. Okay, what is the square root of 4? 2. So you pull that to the outside. And so you're going to have 2. And we cannot simplify the square root of 3, so you leave it radical 3. So 2 radical 3 is our simplified answer. Okay. So the square root of 12 is 2 times the square root of 3. Okay, so 72 is a fun number because there's a couple of different squares that go into 72. But you want to use the largest square that goes into that number. Because if I use 4, 4 does go into 72. I'm going to have to keep on taking square roots until I get it more simplified. Okay, so your radicals are simplified if there are no more squares that go into the numbers under the radical. So 72 falls between 81 and 64, doesn't it? Does 64 go into 72? That's power.
No,
Good job. Does 64? Does 64 go into 72, y'all? No. Does 49 go into 72? Does 36 go into 72? Yes. So that's going to be my largest. Okay, so there are other numbers that go into 72 that are squares. 9 goes into it and 4 goes into it, but that's not the largest. We want to use the largest one because it makes our problem more simplified and causes us less work. So what times 36 equals 72? So we make that 36 times 2, or radical 36 times 2, rather. And what is the square root of 36? So we pull that to the outside. And so we have 6 radical 2. Does that make sense how we do that? So the one that's the perfect square, we take the square root of it, pull it to the outside, and the one that's left we leave under the radical. Okay, so y'all help me do square root of 90. So look, you only care about squares. If it's not on that list, as in one of the ones under the equal sign, I guess I need to underline those red. Are you squeezing? So if it's not on the list of squares, then you don't care if it goes into 90. Like I don't care that 45 goes into 90 because it's not a square. Okay? So I only care about these numbers. Now, do we have any of those numbers that go into 90? 9. 9 times what equals 90? Now, is 9 the largest square that goes into 90? Yeah, and it's the only one besides 1, actually. So 9 times 10. And what is the square root of 9? 3. So we bring it outside. 3 radical 10. Very good. Any questions? Okay. So we're going to do one more together. Then you guys are going to try these U-tries over here. So radical 52. What is the largest square that goes into 52? I like to place 52 falls between 64 and 49 on the chart, and I just like to go up from there. That's how you hit the largest one. So y'all do it and tell me what you think is the largest square that goes into 52. 4. Yeah, it's 4. You have to go all the way up to 4 because none of the other squares go into 52. Do y'all agree? All right, so 52 is 4 times what? 13. So it's radical 4 times 13. And what is the square root of 4? Pull it outside, so it's 2 radical 13. So any questions before you try some on your own? Okay. So you guys try those 2, please. All right, when you get your 2 answers, go ahead and check them with somebody, please. Should have radicals in your answers, no decimals. All right, so what did y'all have for the largest square that went into 20? 4. So you change that to radical 4 times what? And what's the square root of 4? So did you get 2 radical 5? Raise your hand if you got 2 radical 5. Any questions? All right, so 125. What's the largest square that goes into 125? 25 times what? And what's the square root of 25? So what'd you get for your answer? 5 radical 5. So raise your hand if you got 5 radical 5. Any questions? All right, so we're going to add to that. And we're going to multiply with radicals. Now, the rule for multiplying two radicals is you multiply outsides with outsides and insides with insides. You multiply outsides times outsides and insides times insides. You don't multiply an outside with an inside or an inside with an outside. Okay? When I say outside, I'm talking about the little coefficient, the number outside the radical. The inside of radicals are called radicands. Y'all might remember that from your vocabulary. Radicand with a D on the end. So if you hear me say the word radicand, I'm talking about the numbers inside radicals. So I've got radical 3 times radical 15. They're both inside the radical, right? So I multiply them together, and I keep that answer inside a radical. So radical 3 times radical 15 is radical 45. Are y'all okay with that? And then we simplify that the same way we simplified our first examples. We want to look for the largest square number that goes into 45. So which is the largest one of my squares that go into 45? 9 times what? So that's radical 9 times 5. And what's the square root of 9? So this one is 3 radical 5. So you multiply your two insides together and then simplify. So problem G says 3 radical 2 times radical 24. 3 radical 2 times radical 24. So the 3 doesn't have another outside term, does it? Well, technically it's a 1. So 3 times 1 is 3. So it's just 3 on the outside. And then radical, then you multiply your two insides together. So what's 2 times 24? 48. So I've got 3 radical 48. And then you need to try to simplify radical 48 by looking to see what's the largest square number that goes into 48. 16. 4 goes into it, but it's not the largest, okay? So it's 16. So that's 3 radical 16 times what? 3. Now what's the square root of 16? 4. But I've got a 3 already on the outside. Well, it's 3 times 4, which is 12. That's right. So you take the square root and times it on the outside. So it's going to be 12 radical 3. Okay, so if you already have a number out there, you multiply it times the number that you're getting for your square root. So that was 12 radical 3. Does that make sense? Okay. So problem H right here says 2 radical 8 times 3 radical 10. 2 radical 8 times 3 radical 10. Outsides times outsides and insides times insides. So what's 2 times 6 for my outsides? Well, I meant 2 times 3 is 6, right? Sorry, my bad. Times radical, what's 8 times 10? 80. So that's 6 radical 80. Everybody okay with that? Then we simplify radical 80. So I'm looking for the largest square that goes into 80. 16, right? So 80 is 16 times what? So I change it to 6 radical 16 times 5. And what's the square root of 16? And what do I do with that 6 on the outside? Multiply it times 4. What's 4 times 6? So that gets me 24 radical 5. Y'all getting this? Y'all getting the hang of it? It's not so bad. Oh, you say a variable, or are you saying what? Yeah, so what happens there? Oh, okay. Good job. So, outside times outside, inside times inside. What's 3 times 4 on the outside? Times the square root of what? 100. Now, what's special about 100? A perfect square. So that means when I take the square root of 100, I don't have any radicals left, right? It's just a number, right? What is the square root of 100? 10. So this is the same thing as saying 12 times 10. 12 times the square root of 100 is the same thing as 12 times 10, correct? Does that make sense? So if it's a perfect square, then take the square root of it and just multiply by that number. So what's 12 times 10 equal? 120. So you're not going to have a radical in your answer if what's under the radical is a perfect square. Does that make sense? You will not have radicals left in your answer if you can take the square root and get a perfect square. Okay? If you can take the square root of that number, you will not have a radical in your answer. So, we haven't seen anything with variables yet, and this is algebra class, not arithmetic class, so we've got to see variables. So that's what's happening to us next, is we got numbers and variables in the radical. So, if you have numbers and variables in a radical, the first thing you're going to do is give each term its own radical. So I'm going to say this is radical 25 times radical x squared. Well, it's 25. Yes. Getting there. So what's the square root of 25? It's a perfect square, so it's just plain 5. And like my friend has told me, a square root and a square cancel each other out, right? Right? So it's a perfect square too, right? So the right square root of x squared is just x. So this answer is just 5x. So if you have numbers and variables, you give them each their own radical. And then you simplify them each separately. Yes. Yes. So here's a little helpful hint. Variables, I'm going to highlight this, are perfect squares when they have even exponents. Variables are perfect squares when they have even exponents. What are even numbers? Yeah, anything that ends in a 0, 2, 4, 6, 8, right? So, problem K says the square root of 9x to the third. So the first thing I'm going to do is give them their own radical. So that's the square root of 9 times the square root of x to the third. Square root of 9 is easy. What is the square root of 9? 3. It's a perfect square, so I just keep it 3. But I've got to do a little bit of work to fix square root of x to the third. Is it a perfect square? No, because it doesn't have a what? It doesn't have an even exponent. It has an odd exponent. So I want y'all to watch this carefully. When you have an odd exponent, you're going to knock it down 1. X to the third power is the same thing as x squared times, that's supposed to be a square. My handwriting's terrible. X squared times x to the first, right? Remember exponent rules? To multiply, you add the exponents if they have the same base, right? So what you do is you knock it down 1. If you have an odd and you knock it down 1, it's going to be an even, right? Right? And then you just multiply it times 1, and that gets you to multiply back to what you started with. All right? We can't take the square root of x, but we can take the square root of x squared, can't we? What is the square root of x squared? Just x. So that goes to the outside. So I have 3 times x radical x. Does that make sense? The square root of x squared is x. I pull it out, and I still have an x to the first. So my answer combined together is 3x radical x. Yes, sir. Yeah, and that takes a long, long time. If you need to do that, do that.
I mean, in that situation, that's when I would have done it, because 9 came out 3, x,
I get you. I get you, but I know where you're going to in Algebra 2, and you won't have time for that. But yes. My husband does factor trees as well. I do not. No, I'm just kidding. Yes, but if you need to do that, that is fine. I like that, but I'm not going to do that. But yes, I'm open to multiple ways. All right, so let's do this one. We got different x. We got x's and y's. So everybody's getting their own radical, and I'm going to come down here and do it. Radical 40 times radical x to the 4th times radical y to the 5th. So we have to simplify all 3 of these radicals and then combine our stuff together. Okay? I like to do them each individually. So I'm going to take radical 40 and simplify it all the way down, then radical x to the 4th and radical y to the 5th. All right? So radical 40, what's the largest square that goes into 40? Huh? The largest square that goes into 40. It's just 4, right? 4 times what? 4 times 10 is 40. And what's the square root of 4? So this is 2 radical 10. Is everybody good with that one? Okay. Is x to the 4th a perfect square? Is it? Yeah. What times itself do you think makes x to the 4th power? X squared times x squared, right? So this is just x squared. Perfect square. You just divide it by 2, and it tells you what does that. Isn't that cool? Those are nice and easy. So when you have an even exponent, you just divide by that exponent by 2, and it tells you what the square root of it is. Okay? But when we got a little odd over here, okay, little odd exponent over here. So remember, we take that y to the 5th and knock it down 1 to y to the 4th times y. Okay? And what's the square root of y to the 4th? Y squared. Bring a y squared outside and leave a radical y on the inside. And then when you finish up everything, you're going to put all your outsides on the outsides and all your insides on the insides. Okay? So on the outside of a radical, I'm going to have a 2, an x squared, and a y squared. And what's going to be on the inside? A 10y. So I separate all my numbers and variables, separate all 3 of them, simplify them all, and then put your outsides on the outside and insides on the inside. Anything that's a perfect square will go to the outside. Is that good? So what do we do with odd exponents again? Knock it down 1, multiply it times 1 extra variable, and then take the square root of the even one. Pull it on the outside. All right, look at M. It says radical 54 a squared b to the 6. Bless you. Radical 54 a squared b to the 6. So what do we do first? Yeah, we'll give them all their own radicals. So radical 54 Those variables are going to be nice to me, aren't they? How do I know those variables are going to be nice to me? They're all evens. They're all even exponents. Okay, so we just got to really worry about the square root of 54. So what's the largest square number that goes into 54? 9 is, isn't it? 9 times what equals 54? So radical 9 times 6. And what's the square root of 9? 3. So that is 3 radical 6. Is everybody good so far? All right, what's the square root of a squared? This is even. Drag it all the way down. What's the square root of b to the 6th power? B to the 3rd. You just divide them in half to take the square root of variables. All right, so what all's going on the outside then? 3ab to the 3rd times radical what? 6. And I know my b's and my 6's look alike. I apologize. It's a flaw. I have very few. One of mine is that my b's and my 6's look alike. Just kidding. I have many, many, many. All right, so this one, we haven't done one yet like this, where you have to multiply and then simplify when you have numbers and variables. And these are all radicands. They're all inside the radical. So you just multiply your numbers together, your x's together, and your y's together. How do you multiply x's and y's together? You do what to their exponent? You add their exponents. Very good. So the numbers you just multiply straight up. What's 30 times 2? 60. And if you want to, save yourself a step and go ahead and give them separate radicals. So radical 60 times radical, what do I get when I multiply my x's? X squared times what do I get when I multiply my y's? Y to the 5th. So I skipped this step right here where you put them all under one radical. And I went ahead and separated them when I multiplied. Is that okay with everybody? Because I'm out of space over here. I don't know why I didn't give myself enough room. All right, so then I'm going to do my each one separately. What is the largest square that goes into 60? Four times what? 4 times 15 equals 60. 4 times 15. And what's the square root of 4? So that is 2 radical 15. Is everybody good with that? What's the square root of x squared? Drag it down. And what do we have to do with y to the 5th? To radical y to the 4th times y. And what's the square root of y to the 4th? So it's y squared radical y. Everybody good there? All right, what all goes on the outside? 2xy squared radical what? 15y. There's that. All right, I want you guys to try these two problems. Yes, sir. As long as you can show it, I'm good. As long as you get it right, as long as you can show me what you're doing, I'm good with it. I'm not one of those people who can take it away.
How do you do it that way?
Unless it's edited. But as long as you can explain on paper your way, I'm good. I just don't do all that because I know what algebra 2 and geometry are going to look like. You can check your answers with the neighbor when you're finished. All right, so what did you do first on number 1? What did you do first on number 1? Give them the radicals. So you had a radical 150 times radical a to the 4th times radical b to the 3rd times radical c squared, right? What did you get for your largest square that goes into 150? 25 times what? And what's the square root of 25? So you got 5 radical 6 for that, right? Is a to the 4th a perfect square? What's the square root of a to the 4th then? A squared, drag it down. Is b to the 3rd a perfect square? No, so what do you have to do to b to the 3rd? B squared times b, and what's the square root of b squared? So did y'all get b radical b for the b's? And is c squared a perfect square? Yeah, what's the square root of c squared? So you drug that down. And now you just write down all your outsides in the outside and all your insides in the inside. So what all goes outside? B and a C times radical, what goes on inside? 6b. And here I am again with my 6's and my b's looking alike. Raise your hand if you got that for your answer for number 1. Any questions? Y'all should feel smart simplifying these radicals. This is cool stuff. All right. So the next one, everything's under the radical, so you had to multiply them, right? And I'm going to write down this step. If you skipped it, that's cool. 2 times 10 is what? 20. And x to the third times x is x to the fourth. And then I'm going to give them their own radical now. Radical 20 times radical x to the fourth. What's the largest square that goes into 20? 4. And 4 times. And the square root of 4 is what? So that's 2 radical 5. Is x to the fourth a perfect square? Yeah, what's the square root of x to the fourth then? X squared, drag it down. And then outsides with outsides, insides with insides. What goes on the outside? 2x squared and then radical 5. Raise your hand if you got 2x squared radical 5. Awesome job. So this is not the end of this section. This section really is very long. So we're not going to cover all of it today. But I do want to start with some fractions. Okay? I do want to start on a few fractions. So these will be my last 3 examples. We're going to pick up with example R tomorrow. And just going through the alphabet. Now, I technically could cover this whole section, but I'm not going to. Because I want us to stop here and practice what we know so far. You're welcome. Because if we're not comfortable with this stuff, then tomorrow we're going to get really extra confused. So I'm just going to wait and give us another day to practice this stuff first. So, square root of a fraction. If you're taking the square root of a whole entire fraction, then what you want to do first is give the numerator and the denominator their own radical. Okay? So that means this is the square root of 16 divided by the square root of 25. And what's special about those two numbers? They're both perfect squares. So we can just take the square roots of those and get regular numbers. So what's the square root of 16? 4 over the square root of 25. So all we have to do is make sure that fraction is simplified. And 4/5 is a simplified fraction. Okay? So when you're taking the square root of an entire fraction, you give them each their own radical. So problem P says the square root of 13 over the square root of 100. So that's the first thing I do is give them their own radical. So radical 13 over radical 100. And then you try to simplify each of the radicals. So is there any, 13 is prime. So is there anything that goes into 13 that's a perfect square besides 1? No. So radical 13 will not simplify. There are no squares that go into 13 besides 1. So you have to leave it radical 13. And what is the square root of 100? 10. So you just leave it radical 13 over 10. It will not simplify any further than that. So that's all you can do for that. It's absolutely okay to leave an answer like that. All right, so the last one is the square root of 28 over x squared. So what's the first thing we do when we take the square root of a fraction? Give them both their own radical. So I'm going to have radical 28 over radical x squared. And then you need to simplify them individually. So radical 28, let's start with that. Is there a square that goes into 28 besides 1? 4. So we can simplify that one. So that's radical 4 times 7, right? I'm just going to cross my numerators. And what is the square root of 4? So that is 2 radical 7. And I'm going to leave that alone for a second and work on my denominators. What's the square root of x squared? X. You just drag that across the bottom. And 2 over x will not simplify. So you can simplify outsides of radicals as a fraction, but 2 over x will not simplify because we don't know what x is. So this is your answer. Now notice that every one of them that we just did, all three of those, the denominator was a perfect square, right? We did not leave any radicals in a denominator. The reason is because it's not simplified if you do. So tomorrow, the first thing we're going to start with is what happens when you have a radical in a denominator. Okay? So that's what we're going to pick up tomorrow. So we're going to stop right here for today. This is the end of today's lesson, part 1 of section 11.2. Have a good day.